Okay, today we're going to be talking about simplifying radicals. I'm going to give you two different ways to do it. I personally don't care which method you use, so kind of whatevsies. Method number one is what I normally do because I am lazy. So what I have over on this part of the screen, while that mouse is in the way, I've got a list of perfect squares, 1 through 20, and basically they're square roots. So when I'm trying to simplify a radical, what I do in my head, thank you, is I go through and I take the number I'm trying to simplify and I divide it by these numbers that are on the right. 1, 4, 9, 16, 25, 36, that stuff. Once I do that, most of my job is done. Otherwise, I've got to go through and divide it into its prime factors, which I'm usually too lazy to do. So for instance, if I had the square root of 252 here, I'm going to go and I'm going to start dividing by my perfect squares, or I could just divide by 1 through 20 and figure it out. In this case, I divided by 2, didn't work. Divided by 3 didn't work. Divided by 4 didn't work. Divided by 6 didn't work. When I got to divide by 7, I saw that it was 7 times 36, and 36 is a perfect square. So I can break this problem, square root of 252, up into the root of 7 and the root of 36. And the root of 36 turns into a 6. We keep that on the outside. The square root of 7 I can't do anything with, so we just keep it, and that's the answer. It's done. So here's a couple other examples. This honestly should be a review. We did this stuff in geometry. So the 27, I would say, okay, can I divide that by 3? Yes, 3 times 9. 9's a perfect square, so 9 comes out of the house as a 3. What's left inside was the 3 from before, and we get 3 root 3 as our answer. 18, I can divide by the perfect square 9, and I get 9 and 2. The 9 comes out as a 3. What's left is root 2, so we get 3 root 2. 112, if you start dividing by your numbers, the first perfect square you can divide it by is 16. So the 16 comes out as a 4. 4 times 4 is 16. I'm going to multiply that by what was already outside, which is at 5. So the outside stuff is 5 times 4, 20. And the inside was what I was left with, which was a 7, so it's 20 root 7. So if I look at it as two different pieces, like this one, 72 is 9 times 8. 9's a perfect square, so it comes out as a 3. And then, let's see, 3 times 8 is 24. Then I'm left with a root 8 inside. I can further simplify the root 8, that's 2 and 4. The 4 comes out as a 2, which 2 times 24 is 48. And I'm left with a root 2. So the other way you could do it is by doing the prime factorization and seeing what pair you can bring out. And once you've brought out that pair, whatever's left stays in the house. That's another option. I don't like doing that, but you're welcome to if that's your jam. But anyway, I think the easiest way to do it is if you have this table in front of you, this 1 through 20, and the squares table. That's what makes it go a lot faster for me.